Hey, what's going on, guys? Welcome back to another video. Today, we're going to be proving trig identities. Now, this is a grade 11 concept we've been doing since grade 11. In grade 12, it changes up a little bit, but the basis is still there. Now, some of them can get long. They can get very confusing. That's why I'm here to hopefully give you guys some tips, certain ways to do things, how to look at trig identity questions, and how to solve them really fast and, well, effectively. Before we jump into it though, I'm going to use an example that my teacher used like in grade 12, sort of to give you a feel of what we're doing with trig identities. Now, it may seem a little strange, but like stay with me. Basically, you have a word, coat and vase. And in the middle, we have three different changes. We can do this 3 times where we change one letter at a time. And the word still needs to be a word. For example, this one here. We see that it needs an S in the end, and we see third letter. C-O-S-T, that's a word. So that's our first one. Cost. Okay, what else do we need to do to this to get to vase in 2 more steps? Well, let's see. Let's change the O to an A, for example. So C-A-S-T. That's still a word, right? Perfect. Now let's change the T to an E. Case. That's still a word. Now from here to here, all we're doing is changing C to V. So that's sort of like the steps kind of thing. I want you guys to try this on your own. Try to get from plug to stay in 3 steps. Only changing one letter at a time and making sure it's still a word. And I'll show you guys what I got. So I went from plug to slug. I changed the P to an S. From slug to slag, which, yeah, it's a word. I don't know. Crazy how that works. And then from slag to, I think it was slay? Yeah. Just like that. Now, what this is supposed to sort of show us is that I could have went from plug to stay. Or I could have went from stay to plug. Or I could have done maybe plug to slug and then slay to slug. Basically what this is trying to show us is what we're trying to do. We're not really changing anything when it comes to trig identities. We're just rewriting it. And we're proving that they are equal, QED, right? Anyway, with all that being said, let's jump into the trig identities. Alright, let's start off with example number 1. Now, some very key things to remember when we're proving trig identities is look for the following. Look for any differences of squares or differences of cubes. Those are slid in there too sometimes, trust me. Differences of squares, differences of cubes. Look for anything you can factor out. Then after you've looked for all that, more often than not, one side will be a lot easier to take care of than the other. Sometimes you have to do stuff to both sides. More often than not, you don't. But work with the side that is easier right away. That will make everything a whole lot easier. Also, other things to remember. Tan x is equal to sine x over cos x. 1 minus cos squared x is equal to sine squared x. And the other way around. 1 minus sine squared x is equal to cos squared x, just like that. Also, cotangent of x is equal to cos x over sine x. Now that's just some stuff to remember. It helps a lot, trust me. It's 4 simple rules to remember, really. You won't forget them. With all that being said, let's jump right into the question. So it's cos 4x minus sine 4x equals 1 minus 2 sine squared x, and that's it. So when we're doing trig identities, we don't want to move anything over. We treat it left side, right side. So, left side there, right side here. 1 minus 2 sine squared x, and we have cos 4x minus sine 4x, just like that. I'm hoping you guys see on this side we have a difference of squares. this can become cos squared x minus sine squared x times cos squared x plus sine squared x, just like that. Sorry about the cut, my camera died. As I was saying, on this side, we have a difference of squares, right? So we've turned this into cos squared x minus sine squared x times cos squared x plus sine squared x. Now, from here, we want sine x in our final answer, or at least this is showing us that we want sine x in our final answer. So let's turn all the cos squared x's into sine x, or sine squared x. And the way we do that is, like I said earlier, 1 minus sine squared x equals cos squared x. So we're just going to sub that in. It becomes 1 minus sine squared x minus sine squared x times, and we'll just do the same right here, 1 minus sine squared x plus sine squared x, just like that. Now from here, all we do really in this bracket, negative sine squared x plus positive sine squared x, that just becomes 0, and the 1 stays the way it is. On this side, however, it's negative sine squared x minus sine squared x with a 1 in front. So it's 1 minus 2 sine squared x. And this bracket, like we just said, remains 1. And just like that, if we FOIL it, but we know multiplying by 1 just keeps it the same, we get 1 minus 2 sine squared x on our left side. And on our right side, we have 1 minus 2 sine squared x. Just like that. So, this is done. We can write therefore QED. Let's move on to the next one. Okay, so moving on to our next example, we have sine cubed x minus cos cubed x divided by sine x times 1 minus cot x is equal to 1 plus sine x cos x. Now this one's a little tricky. It was actually on one of the tests, and a lot of people didn't get it. Let me show you how. Let's walk through the steps. Step number 1 is we see a difference of cubes here, hopefully, so let's take care of that. This would then become sine x minus cos x times sine cubed x plus cos x sine x plus cos squared x, just like that. Okay? And then from here, we're also going to turn this cotangent, we're going to turn it into sine and cosine terms, because our final answer doesn't actually contain any tans, so we want to change it up. All this is going to be divided by sine x, 1 minus, and cotangent is cos over sine, cos x over sine x, just like that. Now, something that should always be done, as soon as you see a 1, 1s are your go-to, like they're your key basically. As soon as you see a 1 can be anything over itself. And in this case, we want to make it the same denominator, so we're going to change this 1 to sine x over sine x. Real quick, let's do that. Sine x over sine x, that's still 1. And now from here, let us do the next step. Now, the top, we want our final answer to be in terms of sine and in terms of cos. So by doing that, we can either change all of the sines that we know or all of the coses that we know into the other one. But we want to make it one term, really. So let's keep it going. It becomes sine x minus cos x. And I'm just going to change the sine squared x. So this becomes 1 minus cos squared x. All I did was change that term into this. They're equivalent. Plus cos x sine x plus cos squared x. And in the denominator, sine x minus cos x over sine x times sine x. just like that. Now, from here, a lot of things happen. When we're multiplying these two, these sine x's actually cross out. They become 1s. And over here, we have negative cos squared x plus cos squared x. So these also become 1s, just like that. So now let's rewrite what we know. We have sine x minus cos x times 1 plus sine x cos x, just like that. All I did was just flip them, really, just because, you know. And we're dividing it by, since these became 1s, we're just dividing by sine x minus cos x, just like that. And now from here, this is where you guys should be like, oh, because from here, these two are the same term. So they just cross out just like that. And our final answer, or sorry, our final reduction, I should say, is 1 plus sine x times cos x. Now let's take a look at the right side. Sorry, I'm just going to do that. Our right side is 1 plus sine x cos x, just like that. Are they equal? Yeah, they are. Did we follow everything correctly? Yeah, we did. Therefore, QED. Let's move on to the next question. Here we have secant squared x minus secant squared y is equal to tan squared x minus tan squared y. Now, here we might be inclined, oh cool, that's a difference of squares. It is, but both of our answers here on both sides, each side is a difference of squares. So do we really have to? No, we don't. Now, let's get right into it. Secant is 1 over cos of x. So we're just going to change this to 1 over cos squared x minus 1 over cos squared x, okay? Sorry about that. I made a mistake. That should have been a y. Anyway, from here, remember what I said in the last example about 1s, how they're like a key? Well, they are. Let's take a look at this. If we're saying that sine squared x equals 1 minus cos squared x, then 1 is equal to sine squared x plus cos squared x, just like that, right? And that's accurate. When we add these two, we get an answer of 1. So now all we're going to do is we're going to sub this whole thing as our 1, and we're going to simplify from there. So it becomes sine squared x plus cos squared x over cos squared x. And this one we're going to use y's, so it becomes sine square y plus cos square y all over cos squared y. So now from here, I'm hoping you guys know how to break up fractions like this. If you don't, I'll give you a really short example. If I have the following, 3 over 5 plus 1 over 5, we know that it becomes 4 over 5. But how did we do that? Well, we added the tops, right? We did 3 plus 1 over 5. So basically all we're going to do is we're going to take this term and we're going to break it into our two components to simplify that. So let's do it. This now becomes sine squared x over cos squared x, just like that. And there's a plus between them, so we're going to use plus. Plus cos squared x over cos squared x. And now there's a minus, and that minus goes all the way through. But anyway, so now it becomes minus sine squared y over cos squared y. And again, minus because the minus gets ran through. Minus cos squared y over cos squared y. Now, if you don't understand what I just did, take a look at these two just by themselves. When we add them, the denominator stays the same, but all we're doing is sine squared x plus cos squared x, right? This whole thing is equivalent to that. Anyway, from here, I'm hoping we see what happens. Sine squared x over cos squared x is just tan squared x. Perfect. Cos squared x over cos squared x is just 1. So plus 1. Now sine squared y over cos squared y, tan squared y. And cos squared y over cos squared y, just 1. So minus 1. Now here we have plus 1, here we have minus 1. So those zero out. And our final answer is tan squared x minus tan squared y. Now, let's real quick just take a look at the right side and make sure you're showing this on your tests, quizzes, all that. Our S, we have tan squared x minus tan squared y. Are they the same? Yeah. Therefore, QED, just like that. Let's do a couple more. Okay, let's do the next. So here is secant of x minus cos of x times cosecant of x minus sine x equals tan x divided by 1 over tan squared x. Now, which side do we want to play with here? Well, personally, I'd play with that side, but it's up to you. You could, in theory, play with this side. And you know what? Just to switch it up a bit, let's do that side. So, I'm just going to do it over here. This is right side. Let's change all of our tans and our 1s into stuff we know. So tan x is sine x over cos x. And we are dividing it by the 1, I'm just going to change it to cos x over cos x. Actually, I'm sorry, cos squared x over cos squared x. You'll see why in a second. Plus just like that. So now that we have this, let's add that. So this equals sine x over cos x divided by, this becomes cos x plus sine x, sorry, cos squared x plus sine squared x, as we know, is equal to 1. 1 over cos squared x, just like that. And we have a division, so let's flip. So this now becomes sine x over cos x times cos squared x, just like that. And we can simplify this, so this just becomes sine x cos x, just like that. So now that I've done that, I'm actually going to do basically the same thing, but not to this side. Now we're going to play with the left side. Sorry about that, I'm back. Anyway, now that I've, hopefully got a little more room, I've just changed our secant into 1 over cos x, and I've changed our CSC, our cosecant, into 1 over sine x. So now from here, we're just going to multiply it through. So 1 over cos x times 1 over sine x is 1 over cos x sine x. That times that is equal to negative sine x over cos x. Now this times this is negative, cos x over sine x. And that times that is equal to positive cos x sine x, just like that. So, from here, what do we do? Well, we can keep going. My bad. 1 over cos x sine x can't really do anything. We can change this to a tan. Now, do we want to change it to a tan? We can either keep going with this as it is to get to that answer, or we can keep going with it to get to this answer. And just for the sake of the way I did this question, which I would not recommend, by the way, I'm just showing you that there's multiple ways to tackle a question. For the sake of that, I'm just going to simplify this down to this. But hopefully you guys realize from here it would be really easy to turn this whole thing into that. So from here, this 1, like we've done in the last 2 questions, we're going to change it. We are going to change it into sine squared x plus cos squared x, just like that. And now, sine x over cos x is the same as saying what? It's the same as saying tan of x. Cosine, cos x over sine x is the same as saying cotangent of x. And at the end here we have plus cos x sine x, just like that. Now, same thing that we did in the last question, we're going to break this up. So it becomes sine squared x over the whole denominator, just like that, plus cos squared x over the whole denominator, so cos x sine x. Now from here, I'm hoping what you guys see is, now that we have it like this, we can cross that out by using our exponent rules, of course, and this 2 now just becomes a 1. So this becomes sine x over cos x, which we know is just tan x. Let's do the same thing here. This cos and that cos, well, that can become 1, and this exponent is now 1. So now we have cos x over sine x, which is just cotangent of x. So let's just real quick finish writing this off. Minus cos x plus cos x sine x, just like that. And from here, what we actually see is, sorry, let me just finish writing it. Cos x sine x, perfect. Tan x minus tan x, these zero out. Cotangent of x minus cotangent of x, these also zero out. And we're just left with cos x sine x, just like that. Now, are these the same? Yeah, they are. They're the exact same. So, therefore, Q, E, D. Let's do the last one. Okay, so now the last one in this video. Tan x plus tan y divided by cotangent of x plus cotangent of y is equal to tan x times tan y. Now, hopefully you guys know what to do first. If you don't, I'm here to walk you through it. First thing we see here is cotangents, and they're in the denominator. So what can we do from that? Well, let's rewrite it. And I'm hoping you guys see that since both of our sides are given in terms of tan, we don't actually need to change them to sine over cos or anything like that. We can leave them as they are. We don't need to do anything. So let's rewrite this. This becomes tan x plus tan y. And I'm just going to write division 1 over tan x plus 1 over tan y, just like that. Now this bracket here, we kind of want to make them the same denominator so we can divide it. So tan x plus tan y divided by, we're just going to multiply each one by 1. So we're going to change this to, I'll just show you the steps actually. 1 over tan x times tan y over tan y. Just like that. Plus 1 over tan y times tan x over tan x. Now the whole point of that was to get them the same denominator, which you'll see in a second. What we did is we multiplied it by 1, and that 1 was what we needed the denominator to be. So from here, oh, I forgot, those are in brackets. Anyways, from here, we get tan x plus tan y, and it's a division symbol now, still, sorry, divided by, this becomes tan y over tan x tan y, just like that. And this one becomes tan x over the same thing, just like that. Now that they have the same denominator, we can actually just add them. So I'm going to do that all in this step. So it becomes tan y plus tan x over that whole thing. Now that it's a division symbol, we can flip it. So this equals tan x plus tan y times tan x tan y over tan x plus tan y, just like that. And from here, boom, crisscross 1, 1, and we get our final reduction to be tan x tan y. Now let's take a look at the right side real quick. Tan x tan y. Are they the same? Yeah, they are. Therefore, QED. So a quick recap of the steps when it comes to basic trig problems. Step 1, look at the terms. If they're all given to you in the same term, you don't need to change anything. If they're not, then yeah, you will need to change stuff. For example, if this side had a bunch of secants and this side had cos, we'd want to change all the secants into cos. If both sides are given in the same terms, we don't really need to do anything. Rule number 2, look for any factoring, any difference of squares, any difference of cubes. Those are very sneaky like that. Anything like that, and just work with it. Go through it. Step number 3, I guess, would be denominators. When it comes to dividing stuff, this is just like my personal preference, but always just like write it divide and then flip it at the end. It shows the teacher you know what you're doing, and you really won't get lost. Like, there's no way you could get lost when you're writing it like that. Anyways, guys, I hope you enjoyed. If you did, please share, please leave a like. In the video description, I will leave a link to the next video, so go watch that. Next video is going to be looking at trig identities, like proving them when they have compound angles in them, stuff like that, compound formulas. It's a little more complicated, but hey, it's a grade 12 part, so yeah, I'll be covering that in the next video. Anyways, take care.